All right, so 6.7, solving trig equations. So we started this in class, and the first couple questions, we want a general equation for the answer. Actually, I'll say a general solution. That's what we're looking for, a general solution. So, you know, when we were looking in class, we were saying that, well, a sine graph, if you have a sine graph, it goes up and down and up and down, and then it's like a wave. So if you have solutions for that sine graph with the x-axis, it's going to be infinite solutions. So that's why this represents my infinite solutions. K is any integer, okay? And we already wrote that as well, so we're just kind of keeping that in mind. So for sine and cosine, we can add or subtract 2 pi, so that's why it's plus 2k pi. And then my other answer is also plus 2k pi. For tangent and cotangent, it's always going to be plus or minus pi, right? So we don't have to do 2 pi, we can just do pi, because we can go to the other side of the unit circle and it's the same tangent value, right? So we did number 1 and number 2 together. The only difference between number 1 and number 2, I'll go like that so we can see both, is for number 2, you're thinking about this as a quantity, so 2 theta. So you set 2 theta equal to, and then we looked at our unit circle and decided, oh, 2 theta is equal to, where do we have a cosine of 1/2? At pi over 3 and 5 pi over 3. So remember, we do plus 2k pi plus 2k pi, because sine and cosine, we can add 2 pi or subtract 2 pi. And then because this is 2 theta, we need to put 2 theta equals, and then 2 theta equals, divide by 2, and then you have theta equals, divide by 2, you get pi over 6, divide by 2, you get k pi. So you can write it like that, and then this one, you divide by 2, and then you can write it like that. So we have 2 general solutions for our solution set, okay? So let's say you want specific answers between 0 and 2 pi. So the first one is pretty straightforward. And when we did it, we said, okay, so how do you generally solve for anything? Well, you get all the variables on one side, right? So go ahead and add sign to both sides, and then I would take the, anything without a variable, I move it to the other side. Maybe you divide to get the sine x by itself, okay. And then where does that happen on the unit circle? It happens at 2 places, 5 pi over 4 and 7 pi over 4. And then for this one, we're just writing it out to see what happens. So plus 2k pi plus 2k pi. So x right here is this plus 2k pi, and then this plus 2k pi. And then we plugged in 0, 1, and 2 to see what happened. If you plug in 0, you just get this. If you plug in 0, you just get this. If you plug in 1, right away it says plus 2 pi. So that's too big, right? So you're supposed to be less than 2 pi, actually. So that's a parentheses. It's not a bracket. So you're supposed to be less than 2 pi. So anytime you have plus 2 pi, it's already too big. So I stop at k equals 0. Okay, so my 2 answers for when this happens is 5 pi over 4 and 7 pi over 4. Okay, the next one is, still pretty straightforward. And then we added 1, and we divided by 3, and then we take the square root, and we realize that the square root is really a 1/2 over root 3 over 2, and we think about where that happens, and there's this plus or minus. So really, that happens like at 4 places. Because where do you have a 1/2 for your sine value, whether it's positive or negative, it's those 4 places. So even if we didn't do this step, we would still have those 4 answers coming from here. So basically, if you have a sine x or a tangent x, so if it's just x all by itself, whatever's on the unit circle, that's how many answers you have. This was a plus or minus, so that's why there's 4 answers instead of 2 answers, right? Okay, so the other one starts to get like interesting. So then we add 1 to both sides, we divide by 2, and then we think about where does cosine equal 1/2? But then that's where 3t is supposed to equal. So then we said, okay, it happens at 2 places. It happens at pi over 3 and at 5 pi over 3. So 3t, this whole quantity, equals this plus 2k pi, because it's a cosine, so I have to like think about, going around the unit circle a bunch of times. So plus 2k pi. Now I'm going to, well, in our notes together, I made them into a fraction first. But then for this one, I like just divide it by 3. Okay, so I think it's easier to make it a fraction first, actually. And then eventually you get this. So I still made it into a fraction over 9 because what you want to do is you want to plug in 0 and 1 and 2 and 3 and 4 until you're over 2 pi. So you plug in 0. If you plug in 0, you just get pi over 9. If you plug in 0, you just get 5 pi over 9. And then you plug in 1. If you plug in 1, you get 6 pi plus pi, which is 7 pi over 9. 6 pi plus 5 equals 11 pi over 9. You plug in 2, and then you get 13 pi over 9 and 17 pi over 9. You plug in 3. When you plug in 3, you get 18 pi plus pi, which is 19. Okay, 19 over 9 is bigger than 2 pi. So what we talked about in the notes is you'll start to see when it's just x, you have generally either 1 or 2 solutions. But then if it's plus or minus, you have like 2 or 4 solutions, right? So you double that. If you have 3t or 3x, instead of 2 solutions, see how we ended up with 6 solutions. So it's basically times 3. However many solutions you would have, you should have 3 times that many. Okay, so number 6. We didn't do this one in class. Okay, so how many solutions might this have? Well, if normally we have 2 solutions for tangent, then if you divide by 2, you should have 1 solution. So let's see what happens, okay? So you're going to minus 3 from both sides, and then you're going to divide by 3, and then you get that. And then we think on the unit circle, where does this happen? It happens at 2 places, technically. It happens at what? 3 pi over 4 and 7 pi over 4, is that right? So I did 3 pi over 4 plus k pi, and then 7 pi over 4 plus k pi. Okay, but I set it equal to x over 2. So it's not just x, it's x over 2. All right, so multiply by 2. Multiply everything by 2, and then you get that. So x equals, and then x equals. Okay, well, right away I can see if I plug in 0, things are okay. But if I plug in a 1, it already says plus 2 pi. So that's going to be too much. So I think about, okay, this is one answer. I plug in a 0, that's one answer. If I plug in a 0 here, this is actually already too big, because what is 2 pi when you're talking about something over 4 or something over 2? It's going to be 4 pi over 2. So really, if we're over 4 pi over 2, it's already too big. Okay, so see how it's x over 2? We usually have 2 answers, but now we just have 1 answer. Okay? Okay, so the last part is actually going to be, okay, what if you have to use a calculator? So like, what if you get to here and then you have to put it into a calculator? Well, you would do like cosine inverse of a half, and then it would spit something out in your calculator, and then you would do 3t equals that. But the problem is cosine inverse gives you 1 answer. In your calculator, tangent inverse gives you 1 answer. So here's what I mean. So let's say you put that, you have 25 degrees. Okay, let's say you have something like sine of theta equals 25 degrees. Okay, so this is fine. You can go ahead and use your calculator, and you can do sine inverse of 25 degrees, and that'll give you 1 answer for theta. But where else is the sine 25 degrees? Well, the sine is 25 degrees here, and the y value also here. So how do you get that second answer? So if this is 25 degrees, what would that be? That would be 180 minus 25, right? So 180 minus 25, I don't know, 155? So right here, if it's sine, it's always going to be 180 minus to get your second answer, okay? So right here, I wrote it in for you. So you can see that's what we did, right? So sine inverse of y equals theta and 180 minus theta. So 180 is pi radians, right? So pi minus theta. So this is the thing. You get 1 answer from your calculator, that one, and then you have to find the other answer. You get 1 answer from your calculator, you got to find the other answer. You get 1 answer from your calculator, you got to find the other answer. How come they're all different? Because sine of 25 is here, is this angle, so sine theta equals this angle right here and right here. Well, what about cosine? So cosine is here, and then the cosine, if cosine theta equals 25, the cosine value, positive x value, would be here. So how would I get this? Well, I would do 360 minus 25. That's why it's 2 pi minus theta. Okay, how about tangent? Well, tangent is the same if you go the other side of the circle. So that's just plus pi, right? So plus 180 degrees, so it's just plus pi. Okay, so an example of how this works is going to be, let's say you have cotangent theta equals 2. Okay, so if cotangent theta equals 2, tangent theta would equal 1/2, right? Because if you flip this, you flip that, and get 1/2. That's not on a unit circle. There's no answer for tangent that's 1/2. So then you put that into a calculator to get theta. And then you get one answer. So it's saying, okay, this is one answer. Well, what about the other answer? So on a graphing calculator, well, on a calculator, you have one answer, but then there's 2 answers for sine, there's 2 answers for cosine, there's 2 answers for tangent, right? So like when we did the unit circles, there were 2 answers where the sine is the same. There's 2 answers where the cosine is the same, like that, right? So then for the other one, you can see all I did is right here, I found the other one. So tangent and cotangent, you just need to add pi, right? And we're good. So this plus pi on your calculator, you have one more answer, all right? What if this is a no calculator question? If this is a no calculator question, how would you answer this? You would answer it by saying this is tangent inverse of 1/2, and it's pi plus tangent inverse of 1/2. Those would be your 2 answers for your solution set if you had no calculator. But if you have a calculator, you put it into your calculator and then you get 2 decimals. Okay? For the 8th one, for the last note, let's take a look at this. So for the last one, all right, you go ahead and subtract 3, you divide by 4, and then you get this, and you go, that's not on the unit circle. Okay, so go ahead and put it into your graphing calculator or your regular calculator, as long as it's scientific. So cosine inverse of -3/4. Okay, this is one answer, and then the other answer is 2 pi minus theta. So 2 pi minus this is going to be 3 point whatever, right? So then you have those 2 answers. Again, what would it look like if you had no calculator? If you had no calculator, then one of your answers would be cosine inverse of -3/4, and the other answer would be 2 pi minus cosine inverse of -3/4. And sometimes you will not be able to use a calculator, and that's going to be your final answer. Why would you not be able to use a calculator? Because if it's multiple choice, or if it's something where you can just, you know how sometimes you can like just plug it in to see what the answer is? So I don't want you to be able to do that sometimes, okay? So this might be your final answer if you're not allowed to use a calculator. You have to know it's this and this. And then if you can use a calculator, then you just write both decimals, all right? So give it a try, give it a try, give it a try. I'll see you for questions at Student Support Meeting.